Let's start with common electronic component symbols. So on your handout you'll see all of the following symbols. They should be complete, and you will have a photograph of one of the items adjacent to the symbol. So let's go through this quite quickly. Here we have a basic resistor. A resistor is represented by a rectangle. Usual ratios are about 4:1, but it doesn't really matter, just as long as it's a rectangle. So that is plain. All of the rest of them are a variation on resistors, which is why I've grouped them together. So this symbol, so this is now a 3-terminal resistor. This is a potentiometer. The most common place you will find that is like a volume knob on perhaps a stereo system or something similar. So this is called a wiper, this third terminal, and that's the bit that moves inside the resistor. On this symbol, so here's standard resistor, diagonal line through it with a flat top. And that means it's a preset resistor. Those are components which you will normally never see unless you take the back off perhaps a television, hi-fi, or some other piece of equipment, and they're usually adjusted in factory before the equipment leaves. The next one, again a line through it with a different flat top, so this is at an angle. This is a thermistor. We'll cover this later, so there's its two legs. Next one is, remember these are electronic circuit symbols, this is a heater. So it's unusual, it's just divided up into 4. Next one, a rheostat. So the arrow or something going through the resistor tends to mean that it's variable, so we can change its value. And the final one in this group is an LDR, a light-dependent resistor. So in electronics we represent light with 2 lines. This works when light lands on the resistor. Technically this is a semiconductor device. We'll cover semiconductors later. So just a very quick word about all of these. This is a plain resistor. This basically is, but it's a heater. All of the others with the extra lines mean that they vary in some way. In this last one, its resistance varies with light falling on it. In bright sunshine, it will have a resistance probably as low as 2 kiloohms, and in total darkness, it'll have a resistance of typically 1 megohm. So that's resistance. Moving on, let's have a look at instruments, measuring instruments. Most commonly they have a letter in the middle, but there are variations. So we could have an ammeter, and it is an ammeter, double M, not an amp meter. So an ammeter. We could have an ohm meter, something that measures resistance. We could have a voltmeter, something that measures voltage. And then we have a cathode ray oscilloscope. Don't worry too much about the symbol, and we're unlikely to meet anything to do with it in this course in the year ahead. A wattmeter for measuring power. A wattmeter is a combination of a voltmeter and an ammeter, and they tend to have 3 terminals. The final one in this group is a galvanometer. Rests in the middle and depends on which way the current passes through it, whether it moves to the left or the right. So it is a center reading ammeter. Let's get rid of that lot. So the next group, diodes. So this is a PN junction diode. We just tend to say a diode, and the end that we would make positive is called the anode, and the end that we would make negative to make it conduct is a cathode, spelt with a C, but we tend to write it with a K. So that is a basic diode. The next one, we've met this before. This relies on light coming into it for it to work. In electronics, we tend to use the word photo. Not always, but sometimes we use the word photo. So this is a photodiode. It needs light to fall on it for it to work, often in the infrared range. This diode you'll probably be familiar with. This is giving light out in the other direction. So that needs light coming in to make it work. This is light going out. So this is a light emitting diode, LED. The last one, sorry, the penultimate one here is the Zener diode. A Zener diode is unusual. Okay, we'll cover that later on in the notes. Usually used as a voltage regulator, something that keeps a voltage stable in some sort of a power supply or electronic system. So those were the common diodes we're going to meet in the course ahead. These next components are related to power electronics. In other words, they conduct a high current. So the first one here is called a thyristor. A thyristor is a variation of the diode. It still has an anode and a cathode, but we decide when to turn it on and make it conduct. So it has a third terminal, and that third terminal is called the gate. Okay, so that's the thyristor, sometimes called a silicon controlled rectifier. We'll do that later on as well. In this same group of components, it's a variation on the diode, and this is a two-way diode. So drawn something like this, and this is a diac. If you like, it's an AC diode. So it has very, very specific uses. And then there is a variation on this, which again has a third terminal. And this one is a triac. Di meaning 2, tri meaning 3. So this component and this component would both be used for lamp dimmers or motor speed control circuits to vary the speed of a motor. And anode 1, anode 2, and gate. We turn this on when we want to make current flow. Quick look at some general symbols. These are wound components. Wound means there's a coil of wire. A straight coil of wire would be an air cored inductor, so there's no core shown. If we put a line over it, or more often it's two lines, that means this coil of wire is wound onto an iron core. So this is an iron cored inductor. This is a relay. The symbols for relays vary a great deal from manufacturer to manufacturer, but this is basically the standard. A range of contacts, and the coil would be within this. This is a transformer, and technically if it's got a line or two down the middle, it's an iron cored transformer. So moving swiftly on, we'll have a look at transistors. Transistors, very simply, the direction of this arrow tells us the type of transistor. This arrow is pointing away, it's pointing that way, so it's not pointing in, not pointing in. This is an NPN transistor. Its complementary counterpart has the arrow pointing in, and it's just the opposite of this. It is P, N, P. Finally, this is a transistor which depends on light for its operation, so light must fall onto the transistor to turn it on. So this would be a photo transistor. Again, we've met the term photo for the arrows for light earlier on. On to capacitors. Capacitors, two sheets of metal separated by an insulator. That's what the symbol tends to represent, two parallel sheets of metal. And this is a non-polarized capacitor. In other words, it doesn't matter how you connect it in a circuit, the polarity doesn't matter. This one, similar to resistors, if it's got an arrow going through it, it's a variable capacitor, sort of component that you may meet in an old-fashioned radio to tune in the radio stations, being superseded a lot these days by something called a varicap. So the next capacitor, again, it's variable, preset. Remember what we did with the resistors, that flat line on the end. This is something you'll never normally see. It's hidden away inside a piece of equipment and would be set at a factory. And that brings us to this. This symbol is slightly different to all of the others. This is a polarized. In other words, polarity does matter. This is a polarized capacitor. The empty side is plus, the filled in side is negative. We normally just indicate plus. So these are very different to these. And again, photographs appear on your handout and we'll go into them later on. Let's finish up with some general symbols. We should recognize this as earth. This is a resistor with a piece of wire through it, so quite literally it has no resistance. To you and me, this is a fuse. So that's a fuse. These are a pair of DC terminals, so it could be a point where we take DC supply out and feed it to a circuit, or a point where we have a supply and we connect it into there to make a circuit work. This is a pair of AC supply terminals. This one is a cell, and this one is a collection of cells put in series one after the other, which we call a battery.